Stépahne, can you tell us why the current electoral system, this current voting system, is unfair? Actually, I'm going to ask you, because you're a mathematician, you have a certain number of criteria that you use for determining fairness and true representativity. Can you explain to us the tools you use to determine if an electoral system is fair and why, and how these tools are somewhat objective mathematically? Can you just speak to that in general and then go over the different criteria that you use?
There are 5 aspects in which I've been able to develop some mathematical measure. So in that sense, we can measure how the electoral system is not exactly unfair, but it lacks precision. Okay, it doesn't give the result it should be, and by how much is the error compared to what would be the ideal objective. Okay. The first tool I've been able to develop is a measure of how many people are used to identify a representative. So in theory, you should always have the same amount of person who vote to choose somebody. Okay, and actually with FPTP and the electoral map we have in Quebec, you can have a variation of 50% from one circumscription to another. It's plus or minus 25, it's even more than 50% when you use one as a reference. So it's unfair, okay? And, the second tool we can use is the fact that we can measure the level of approbation of the people elected. So if you were asking everybody which are the 125 person they would like and which one of them are elected at the end, you could have for each person some rate of satisfaction, and so you can use this and compare with different electoral systems. Typically in Montreal and other places you can have a party that will win the election and has with a participation rate of less than 40%, and the winning party has less than 40% of the vote, and at the end the winners, they represent less than 1 Montrealer out of 6 or 7. So it's we could do better a lot now. We have the tools. Another objective tool that we have is a measure of stability. One thing we can do is simply check for how long a government is stable, will have the support of the chamber, and we can estimate with statistics the risk that it will fall. So if you give some proportion simply to make the difference of opinion between 2 different parties, or the probability that one member of a party will get out of the how do you say, party line. So you can multiply this and obtain some estimation of the probability that a government will lose a confidence vote. So we can do this too. Finally, there's a last aspect that we can measure, and it's not totally mathematical, it's more logical. It's something that we use, is the measure and the resistiveness of an electoral system to the cloning or crowding. This will show you if an electoral system is resistive to a different strategy, one being the fact of cloning an adversarial. With FPTP, for example, if you have somebody that could win an election, like Patrick, for example, the best way to make him lose is to get a friend of him that would say the same thing and that would be candidate in the same riding. So in the end, they would say the same thing, they would split the vote between each other, and instead of winning, he could lose. So those are typical elements that we can have from a mathematical point of view to measure the fairness and the precision of an electoral system, to compare who the people would like to get elected and who really gets elected with the method.